In part 2, we're going to talk about sharing data, caching, testing, exception handling, and logging. Now, this talk is called Beyond the Code. I'm afraid we're going to look at some code towards the end of this section, but it's still important and pertinent to service design. So let's talk about sharing data to begin with. Who's uncomfortable with sharing data? Nobody. Oh, one person is, 2 people are uncomfortable. There we go. Victoria's just trying to help me by putting her hand up. Wonderful.
Corporate data.
Oh.
Like my data, no problem.
So just data within your systems, between your services.
All right.
Yeah. Okay. Cool. So it's not surprising that many of you, well, some of you, are uncomfortable about sharing data, because as software developers, we are taught fundamentally not to duplicate stuff. So relational databases, they exist so that you can reduce the amount of data by making things relate rather than duplicating. We're told not to repeat ourselves when we're writing code. Yeah, we get that code that we need to use in 2 places, we put it in a function and we call the function. Test-driven development even has a step for removing duplication. So as software engineers, we are fundamentally programmed to hate duplication. So I'm not surprised that some of you are really uncomfortable with sharing data. Now, more cultural references. Who knows Star Trek? Yeah, wonderful. So when I was in Colchester, very few people knew who Star Trek was. I mean, there were very few people there, but very few people knew who Star Trek was. And then I made the cardinal sin of saying that this is Captain Kirk and Spock. Okay? Those of you that have seen Star Trek 5, which is an underrated Star Trek movie, in my opinion, will know that that's Spock's brother. Can't remember what his name was. Anyone? No, that was Spock's brother. And he was going around taking away people's pain. So Captain Kirk, I can't remember what his pain was, but there was some pain in his past. So Dr. McCoy's I remember, because Dr. McCoy gave his dying father a way out and killed him, and then next week he found the cure, and that was his pain, and Spock's brother took away his pain. So there's this bit in the film where Kirk goes, because Kirk is always the hero, right? He says, you can't take away my pain, I need my pain, right? So by the end of this section, I'm trying to take away your pain and make you comfortable with sharing data. Are you okay to try that with me? You aren't half as excited as I am, are you? Right. Okay, so here is an example. So on the right-hand side here, we have got a third-party system, which is extremely slow. And in here is all of the information about our owners. And like I said, it's third-party. So on the left-hand side, we've got 2 systems that belong to us. The statement generation system and the owner admin system. I've put in the technologies that are used to build them, just to emphasize what I said in the first half, that you can have services with different languages, different tech stacks. So when you generate statements for everybody once a month, you need to have a list of all the owners. And if it's very, very slow to get from the owner management platform, okay, it just takes too long to generate all the statements. So what I'm suggesting is that we should take the data from this SQL server and we should store it, and we should store it individually for the services. So what we have now is a cron job in this new owner account service, which every so often goes and gets all the data from the slow owner management platform, and it keeps the data in somewhere that the statement generation service and the owner admin service can come and get it quickly and easily. So we've increased performance, okay, in a way that we need. We identified we had a problem. We identified that statements took too long to generate. So we fixed that problem by putting the data somewhere where we can get it quickly and easily. Stephen's shaking his head already and screwing his face up. And also just to emphasize the fact that different services can have different databases. I've included the type of database here. So have I convinced you that if you need a performance, you've identified a performance issue, and the way to do it is to duplicate the data, that you're comfortable duplicating data?
It's just a queue.
If it's read-only, it's just caching, which makes sense. But that's fine.
Yeah.
That's not... It's not sharing data per se, I would say.
I didn't say sharing, I said I duplicated.
Permission constraints, so
yes.
That's fine.
Absolutely. Oh, good.
That's like, but okay.
Why weren't you in Colchester last week?
I guess my only random thought,
yes.
No understanding at all,
yep.
is you have now duplicated the data twice. So you've got 2 kind of like axioms. One was microservices should be independent and therefore the data should sit, and the other was don't duplicate data. By you duplicate the data to solve response issues.
Yes.
but you needn't have maintained the data independence of each microservice. You could create a single second kind of cache read-only database that both with that, and therefore violated your other axiom. So it's whether or not by breaking, duplicating once but less is better than duplicating more but being consistent with your microservice definition.
Okay, so that's a very good point. And the reason we can't do that is this is a third-party service. Okay, this is outside of our control. We can't change it. All we can do is talk to it. So we can't ask it to look at this faster database. Plus, we also talked about earlier on about services not sharing databases. So that's the reason here. So the data is duplicated. I thought someone was going to ask, well, what if the data in one is out of date than the other? So these are eventually consistent, and they are updated in a time frame that works with the rest of the system. There are constraints. It's not perfect, but sometimes this is something you should do. Well, that was easy. Okay, so we go a bit further. So as I was saying earlier, the more independent a microservice is, the more robust it is. So those two previous services were both tightly coupled to the owner account service. So what we actually do is we go a bit further. So when the new data comes into the owner account service, if the data has changed or it's new since the last time we ran the cron job, we pop a message onto the queue. And then the owner admin service and statement generation service can keep their own caches of the data that they can then use for their own purposes. It just reduces some of the coupling between the services. Cool, good, right, but don't get carried away, right? In just about every other context, you shouldn't duplicate stuff. You should definitely keep it separate. But so far, I haven't had anyone zealously agreeing with me that they're happy sharing data and then want to go and share and duplicate other things. So I think I'm on fairly safe ground. Okay, should we talk about caching? So I'm not an expert in caching, but it just so happens that when I was writing this, I was helping solve a caching problem. So I included a few bits and pieces. So for caching, we store data often temporarily. We cache for speed, reduce network overload, efficiency, better user experience, cost, all of those sorts of things. For example, if you're using Contentful, they charge by the API call. So we cache what goes in the we cache what we get from Contentful. So what you shouldn't do is this. So as you can see there in my order service instances, they've all got their own cache, which means that if something is invalid in one of the services, it might go back to Contentful and get an update, but it hasn't been validated in the other two services. So we've got an inconsistency in the data here, which means if your load balancer does one request into order service 1 and the next one into order service 2 for the same data, you might get two different results. Okay, so it's really important that you share a cache. So there are at least two different ways of doing this. This one is where you have a single cache, and each service that realizes that the item cached is out of date then goes and updates it in the cache, and it's there for the other two. Okay, so you've always got consistent data. Or you can put the cache in between your services and the system that you're caching the data from. This just means that the service instances go to the cache and the data is always there. The cache will work out if it's expired, and if it has, it'll go and get it from whatever the source service is. So the important thing really is to think about how you're caching your data and what the consequences might be, and not have multiple caches of the same data, because one day you'll get something that's not right. So yeah, we're back to Boromir. We were talking earlier about naming things and how that's difficult, but of course cache invalidation is also the other thing that Boromir says is difficult, although I don't remember him saying that in Lord of the Rings before he died. Have you noticed how Sean Bean dies in a lot of things? Yeah, it's a shame because he's a fantastic actor. Right, so when you think about caching, you have to think about when you're going to invalidate it. When do you decide that the thing that you've cached needs to be refreshed? So you don't end up with stale data. If it should have been refreshed, then it's gone. We've talked about cache consistency, cache stampede. Okay, so if you've updated your cache and you've got too many services going to the same cache and they all rush for it, something is going to fall over. You do need to think about, again, when to invalidate your cache and clear your cache out so that you don't exceed memory and storage limits. Choose what to cache, right? Cache is one of those things like optimization. You don't do optimization until you know you've got a problem. Right, I'm going to talk about that hopefully at NordevCon next year. You wait until you know that you need to cache something because you've got a performance issue or one of the other things, and then you think about whether or not you're going to cache it. Security and privacy concerns. Okay, you've got your PII, your personal identification. Thank you. Personal identifiable information. Yeah, and it might be in the cache, and the cache might be easily accessible throughout the company, so that suddenly people can go and get information they shouldn't. Complexity and application logic. You've now got to think about where you're going to go and get your piece of data from, and whether or not it's valid, and whether or not you need to go to the cache. So it puts some more complexity into your application logic. And then distributed cache latency. So it may be that it's you need to think about whether or not you can get stuff out of the cache quick enough, which would be ironic if you'd put the cache in to make it faster. Cool, and that's about all of my experience on caching. And to be fair, most of these came from ChatGPT, and I've just learned what they were afterwards, so I could add a bit more. Right, should we have a look at testing and services? Because testing is really important, right? Good, I'm glad you agree. Who's read these? Test-driven development? Yeah, have you read the other one as well? Right, so these are two fantastic books. They're both older than my children is the first thing that springs to mind. Test-driven development by Kent Beck was the original test-driven development book, okay, where you write the tests first, and then you write small units that make the tests pass and that sort of thing. So you get loosely coupled code, and you get regression tests for free. And Growing Object-Oriented Software Guided by Tests, which I appreciate most people probably haven't read, looks at things differently. It starts on the outside of the system and it tests the system interface, okay, because you should be able to triangulate everything within the system, every feature within the system from the interface. Otherwise, how's it going to get called in production? There are exceptions. Sometimes there are bits of code that go on in the background you might have to write a unit test for. And sometimes there are things where you'd have to write so many tests just to test every part of a feature that it becomes impractical. So you then write unit tests inside instead. So those of you that are familiar with the Agile Manifesto, it talks about things that we value and things that we prefer. So while there is value in the items on the right, value in test-driven development, we value the items on the left more. When you're talking about testing services, you're better from starting off by testing from the outside in, rather than writing unit tests inside. So for example, if you've got a database with your service, then you want to test from the service boundary all the way through to the database and back. Okay, it may be that you have a real database. It may be that you mock the database out. It may be that you mock your database, your database library out. But the important thing is that everything from the request all the way through the service and back is tested. And then you know when it breaks and when it's not going to work. It also means you write fewer tests because you're not writing them at the interface level, and then at the service level, and then at the repo level, and further and further. And all these tests you've got to maintain. You've got one set of tests which test from one end to the other. And for every endpoint, it's important that you also test with and without the API key, with and without all of the different things that you have to construct for the message, so you get all of the 400 errors and that sort of thing. It's important that you test all the scenarios. And then as you move on, when you break things, you'll find out more. You'll find out straight away. If you talk to a third-party API as part of your in your service, then make sure that you mock out the third-party API. Those of you that work with TypeScript and JavaScript, there's a fantastic library called Knock, which lets you really easily mock out a third-party API, and it accepts requests and gives you response. So use that if you've got it as well. And again, if you're doing asynchronous stuff, make sure that you test from end to end. It may be that you mock out the AWS library that allows you to send to your SNS topic, for example, but make sure you test from end to end. So the main thing with testing, the primary goal is to prevent regression. So most of us are experienced engineers. We don't necessarily need that help in making our implementations loosely coupled. We do that by instinct because we've done it for so long. So the primary thing with testing is for regression. You've changed something in one part of the system and you want to make sure that it's not broken something somewhere else. So you run your tests to see. Oh, I've covered this already. Test everything in every endpoint, okay? Your happy path, so your 200, but your errors, or your validation, or your authentication, okay? Because one day someone will go in and they can't be bothered to go and find the API key that they need. So they just take out that little bit of middleware, okay, that does the authentication, so they can test locally, and they commit it, and it goes into production, and then suddenly your endpoint is wide open. But if there was a test there looking for that piece of middleware, you'd run the test before you commit, and it would point out that somebody has taken out the middleware that does the authentication. Okay, with me so far? Good. Should we have a look at exception handling? Okay, yeah. Oh, wow. So Steve's excited about exception handling. Okay, this is good. I like this. Right, so what's an exception? So in software engineering, exceptions are two things, right? System concept. Something's gone wrong. Sorry, something unexpected has happened, something's gone wrong, and something unacceptable has been provided. Okay, so exceptions map onto real world things. They're not just programming constructs, but they are language constructs. So, for example, I've got loads of these, so I'm only going to read out the first two for each slide. So something unexpected has happened. The application runs out of memory. Yeah, don't normally expect that. It sometimes happens. Or the network connection has dropped out mid-request. Those are unexpected things, which are exceptional circumstances. Something has gone wrong. A requested record doesn't exist in the database. Depends on the database library you use, but sometimes if something isn't there, you get an exception. A file path points to a missing resource. Same thing again. You've deployed, something's not right. That's not expected. That's an exceptional circumstance. Something unexceptional has been provided. So this one's a bit of a grey area. So a request body has been invalidated or has an unexpected structure. So you probably ought to have your middleware just returning 400 for this. But in some cases, when you test the structure of a request, the library that you use to do it sends an exception. It's an exceptional circumstance that something wrong has been sent. However, we expect people to send wrong things. We were talking about it in the first half. So this may not be exceptional. It depends on your point of view, and it depends on your on the library that you're using. So the language construct. So usually it's something in programming languages where an error is thrown and something else catches it and deals with it. Okay, it's propagated. The error is propagated and it's caught somewhere. What happens if it's not caught somewhere? Anybody?
Fatal error.
Fatal error. And what does that normally mean?
Program execution will stop.
Program execution will stop, right? You don't want your services stopping halfway through processing somebody's request. So the important thing is to make sure that when these things happen, we catch them and we process them so that our applications, our services, whatever it is, don't stop. Throw and catch. So this is what it normally looks like. So when I'm talking about exceptions, this is normally what happens. So if something goes wrong, so we throw the error and then we catch it and we deal with it. Okay, everyone familiar with that? Great. So exceptions should signal genuine failure, never to be used for routine control flow. So as I've explained, hopefully, you only throw an exception when something exceptional has happened. You don't use it as control flow. Okay, you don't go through a list and you look out for the third element. You get to the third element and you want to stop there, so you throw an exception. You don't do that. Back in the noughties, a C++ programmer called Andrescu wrote a book on modern C++ design. And one of the things that he described there was using exceptions for control flow. It never caught on, and it was an interesting idea. But exceptions tend to be expensive, and you have to think about how they're going to be handled. So let's look at how we might handle an exception in services, in a received message from an SQS queue, and in a scheduled task. So the first one is exceptions in a controller. So the controller is normally the place that we enter into our service. Normally, with a HTTP request, we get the request and we have to process it in code. So in this example, we're validating the request, and I've chosen that if the request is wrong, you sent me crap data, I am going to throw an exception. And in this case, I would then catch the bad request, return an appropriate message and a 500 status code. If the exception thrown isn't a bad request, then I would catch the error, log the error, return something went wrong, so I don't give away to the client exactly what the issue is, and return a 500. Okay, pretty clear, normal, good. No one's looking out for the bum status code, are they? What did I say in the first half you should do with a bad request? What should you return? 400. And what does it say there? 500, yes. So I've corrected it on the next one. So if you have to write that error handling code, that exception handling code in every controller, it's going to start to get verbose. Okay, and you're going to have a lot of duplicated code. And if you want to change something, add a new exception type that you need to handle everywhere, you've then got to go and change it in every controller. So a lot of languages and libraries support a default error handler. So this is something that you can put into your ecosystem, probably as middleware. And when an exception is thrown, it'll catch it and it'll handle it all in a consistent way, and you only have to write it once. So in this case, if you have if a 404 not found is thrown, then you can return the 404 status code. If a bad request is thrown, again, you can return a 400. And if something went wrong, an error that you don't recognize, you log it and then return a 500. So this takes out the duplication and handles a lot of things in one place. But sometimes there are custom errors that you don't necessarily want to handle in the default handler. There are two ways that you can handle those when you look at controllers and middleware. Sorry, I'm starting to lose my voice. So one thing that you can do is you can catch the error, you can catch the exception. So in this case, a file not found, and you can translate it into something that the default error handler can handle. So in this case, a not found exception, so we throw that. The other thing that you can do is that you can shortcut the default exception handler and just catch and deal with the black magic exception and just return an appropriate message and the appropriate status code. Okay, so there are lots of different things you can do to make sure that you don't duplicate your error handling code, and that you can do exceptions as well. It's really important that you secure your error responses. Okay, think about what you're returning to the caller. Not everybody is a good actor. There are a lot of bad actors out there, and they might take advantage of something that you return in your error message, in your response, that might give away the internals of your system, and allow them to hack it. So think about what you're returning, and obviously don't return PII, file path, stack traces, all those sorts of things. What you should do in that instance is return a generic friendly error and then log the error, so that your system administrators, whoever it is, can then look and find out what the problem was from the logs rather than giving it away to any bad actors. So let's look at exception handlers exception handling in message handlers. So this is often the scenario you see. So you've got work going onto a queue on the left-hand side there. The order service is listening to the work, and then when things go wrong, or if things go wrong, then it puts the message onto the dead letter queue, so that it can be replayed later or investigated. So you end up with a handler that looks like this. Very simple. The message comes in. If everything goes right, you call actions done. Okay, and that takes the message off the queue. If things go wrong, then you catch the exception and you put the message onto the dead letter queue, and perhaps you might log it as well at that point. Cron jobs are similar. Sometimes the scheduler for your cron job will accept an error in response. So when your scheduler kicks off your cron job, something goes wrong, you can return what the error is. Some cases it might not, so you can stick it onto a topic, so that things that are interested in the error that's gone wrong are listening. For the email service I was talking about in the first half, I wrote some error handling code that would put details of messages that had failed to send or had gone wrong in some way onto a topic, so that those services that were interested in finding out when their emails had failed could do something about it. I then discovered that none of the rest of the teams gave a toss about what happened when emails failed. They just wanted to move on. So it was a waste of time, but yeah, it would have worked. So again, in the scheduled task, it's much the same. You run the scheduled task. If there's an error, you publish it to your queue, or you return the error to your scheduler. Okay. Yes.
What's the topic? Is that an AWS product?
Yeah, it's so it has lots of different names and different things. So there's RabbitMQ equivalent as well. So a topic is something that you post a message onto, and then queues listen to the messages on the topic, and there is usually metadata that's associated with the message, so that message queues can find out which messages they want and which they don't. So a topic is just a way of broadcasting, and not really caring who's listening.
In the pub sub.
Yeah.
CPU.
Yeah. Exactly like that.
Contain the actual job request, or it does.
It does.
Oh.
Yeah.
Ooh, I have a question. Producer, consumer.
Yep.
Publisher, subscriber.
Mm-hmm.
Are those synonymous concepts that are different?
Can you ask me one on services? I don't know. I'd have to think about it. Yeah. Sorry. Right, so maintaining context across layers. So sometimes a failure can happen deep down in the stack, and by the time they reach the boundary, the meaning of what's gone on is lost because it's been caught and rethrown, and debugging can become slow and a lot of guesswork. So I'll go through an example in a moment, but you're throwing all sorts of throwing and catching in the stack, and basically information is being lost as you go. So what you should really do is have each layer add context. wrap, don't replace, and log once at the system boundary with the full context. So let me go through an example of that. So you've got a HTTP call right at the bottom of your stack. Okay, it's called out to something, it's called out to another service, and there's a problem with the other service, or something isn't found. So you catch the exception. You can then wrap the exception with the message and some context to do with the HTTP call you made into a hierarchical exception, and then you throw that. And then at the next level, at the business logic level, you then catch that same hierarchical exception. Okay, you can add some more context to it. Okay, so we know that the service has failed because the service in the middle between the HTTP client and the controller has added some more context, and you've got the original error that is then wrapped again. And then the same again happens in the controller. So the controller catches the exception. It identifies that it is a hierarchical exception, so it knows that there's more information there. And then what it can do is it can log the error message, and it can log a context object, which has got all of the information of what's happened as the stack has unwound. So you end up with something like this, okay, with a message like this. So you've got the original HTTP error at the bottom, then you've got the context that was added in the service layer, and then you've got where the next one up is the service layer. So you've got that, and then you've got the error message in the that's logged in the controller right there at the top. Everybody with me? Yeah, cool. So you've maintained your context. Okay, you've maintained the original error and any other information that is pertinent that you've then collected as you wound the stack back up, and then you display it all in one go. What I often see is that you end up with 3 or 4 logs which are all the same. Okay, because you've logged at the service, you've logged at the HTTP layer, you've logged at the service layer, and then they become disparate and they become spread out, and you can't work out what's what. So you keep it all together and log it once. Sometimes, so we were talking about this earlier. Someone was saying, what do you do if your service down the line fails? So you could do the same with response codes, pretty much. So the example here is I'm recording that I've got a HTTP error by typing my exception as a HTTP error, and I'm storing information that's pertinent to that. And then as I go back up the stack, again, I'm building context as I go, all the way back up to the controller. And then in the controller, I look to see if the exception that I've got is a HTTP exception by calling find HTTP error. And if it is, I know that the error originated in an HTTP call, and I should be looking for the status code and the error, so I can dig them out of that type of exception, and I can return appropriately in the controller. I've got at least one confused face. We're all good. Excellent. So common exception handling anti-patterns in services. So I don't believe there's actually anything as an anti-pattern. Okay, it's a term we use, right? But everything's a pattern, and there are good patterns and there are bad patterns. If it's an anti-pattern, it suggests it's not a pattern, but it is. It's just a bad one. So catching and logging exceptions at every layer. Okay, we've looked at that. Don't do that. Swallowing exceptions to keep things running. Yeah. So we've all done that. Well, we don't really care about this at this point, so we'll just swallow it. And then at some point in the future, you do care, and there's no log message. Treat all failures as internal server errors. We looked at that earlier. It's important that you distinguish between your 500s, your 400s, and other things. And retry without understanding the failure mode. So we talked about this in the first half. If you've got a 400, there's no point in retrying because the service has told you, you've sent me crap, I can't do anything with it. But if it's a 500, then you know to retry. Everyone with me on exceptions? Excellent. Let's talk about logging. So logging records the service behavior. Oh, sorry. What is logging? Baby, don't hurt me. Yeah. Hadaway. No, you're all too young, aren't you, really? So I was quite pleased that when I presented this slide without the brackets, one of my team got it straight away and responded with "baby, don't hurt me." So I thought I'd include it. But yeah, I guess you have to be of a certain age for that. So,
Brian Adams' song.
No, it's
Canadians.
It's in what? Sorry, a Brian Adams song.
Canadians logging.
Oh God. Yeah, very good. Yeah, you could have gone with that. We could have gone with Nickelback.
Oh right.
Yeah, but no, it's Hadaway, and it's definitely not rock music, so it doesn't really count. Right, so logging records service behavior, supports debugging, monitoring, auditing, and incident response. Right. So we were talking earlier, weren't we, about traces, logging, and metrics. So if something's gone wrong, you need to be able to see what's gone wrong. code explicitly omits events. You don't accidentally, omit a log. It'd be nice if you did sometimes, but you don't. And logs are durable. You've got to put them somewhere so you can go and look at them after the effect. Log messages should be succinct, useful, and unique. Yeah, people agree with that? It's good. So let's go through some log messages, and you can tell me whether you think that they're good log messages or bad log messages. Are you ready? Can we try that again? Are you ready?
Yes.
There we go. Good. I've finally woken you up. Good. Right. So is this a good log message? What don't?
Depends.
Right. It depends. Of course it does. Right. Who wants to go first?
Well, it's not an error, is it?
No, I mean, it's just the message part, so it's fine, I suppose.
So Delph, are you saying you'd like me to add timestamp to succinct, useful, and unique? We're talking about the message, not necessarily the whole log context, which I'll get to afterwards.
Huh?
Sorry.
Okay,
I'd say the barn was right next to me.
Sorry. Right.
all right. I suppose there must be different stages to processing an order.
Yes.
So, what part of it is it?
What part of it is it?
Yeah, what part of processing an order is it?
It's the end.
A full stop.
Yeah.
Yeah, but why do you have to log things that don't go wrong?
That's a whole other conversation. Yeah. I can't remember if I'm covering it that later, but yeah, absolutely. You shouldn't log for the warm, fuzzy feeling, right? You should log because it's giving you something useful. But we're talking about whether it's succinct, useful, or unique. Do you know, I went to Oxford and did this talk earlier in the year, and they picked me up on everything, but you lot are worse. Right, okay, so what is it? Is it succinct?
Yeah.
Good. Is it useful?
Depends.
I'm going with yes, because it tells me the order was processed successfully. Is it unique?
Yeah.
Yeah.
Yeah, because we've got the order number, right? Brilliant. What about this one?
Oh, not unique. It could have failed many times.
It could have failed many times, yes. But you would hope that it wouldn't retry, wouldn't you? You'd hope if it failed, it would just fail, right? Otherwise, you end up with loads of orders. All right. You're going to make me do this the hard way, aren't you? Is it succinct? Is it useful?
Would it be more useful to have a function that it failed in? Is this the user or the person?
So this is just the message in the log object. Okay, we'll talk about context in a minute where you'll be exactly right. It's not a trick question.
Then yes.
Excellent, thank you. Yes, it is. Right, okay. So it's succinct, there's not a lot of it. Okay, it's unique. It's got the order number in it and it's helpful. It tells you that something's gone wrong in the database. Somebody in Oxford argued that it didn't tell you what went wrong in the database, so it wasn't useful. But, what about this one?
It's kind of useful maybe, but not unique.
It's not unique. Okay, it's definitely not useful, right? Okay, because you don't know what's gone wrong. Yeah, it could be anything. It could be someone's tripped over a cable in the server room. You just don't know. You just don't know what it is. Yeah, so this one isn't very good at all. It's also really important to think about how you log and what you log. This is warm, fuzzy feeling stuff again. Okay, so you would end up here with a lot of unhelpful log messages clogging up your aggregator. Okay, so we may like to do this because we think, yeah, when something goes wrong, I can go and look in the logs and I can see exactly what's happened. But in practice, this all gets lost in all of the noise. So think about how many logs you put in and what you're doing. Understand your log levels, right? Loads of people really like to put stuff as error because you think, well, yeah, if it goes at error, I'll go and look at that and then I'll fix it. But do you? No. So know your log levels. Trace, extremely detailed, low-level information. So on the previous slide, when you're developing something, you might put in a load of trace logs into your function so you can see in production to begin with, or even in dev, what it's doing. But yeah, extremely detailed, low-level information. Most of the time you don't want this. Debug, diagnostic stuff, right? Stuff that you probably don't want day to day, you probably don't want in production unless there's a problem. Info, normal expected events. Yeah. That's warm, fuzzy feeling stuff again. So while sometimes info is really useful, you shouldn't be logging everything unless you need it. I'm a fan of turning off, I think I'll cover this next. I'm a fan of turning off info in production and just having warn and error But sometimes you have long running processes and you do need that warm fuzzy feeling that the process is going to take 12 hours is still running. Okay, but think about how you might do that. And then warn, yeah, something unexpected has happened, but the application can continue. So this to me is something that, I want to know it's happened when it's gone wrong, but I'm not actually going to fix it. Yeah. So David was talking about errors in production earlier. So an error is something that if it happens, you want to go and fix it, right? And if it happens and it happens lots of times, you don't want to fix it, then it becomes a warn. Critical, so I never really use these, but critical, very severe error indicating serious problem that requires immediate attention. Yeah, get off your backside, go and look at what's happening. And fatal, yeah, your service is going to die. Yeah, I haven't actually seen critical or fatal used at all.
Would you record all of these messages in one table within the database?
No, I send them off to Datadog and let it do it.
Oh, I see.
Yep.
Okay. That's unless of course you don't have Datadog.
Unless of course you don't have Datadog, but there are plenty of free aggregators as well. Right, so configure your logging levels. Quick, shall I take a photo? Yeah, configure your logging levels. Okay, think about what you want in production and what you want in development. So as I was just indicating, in development, yeah, info is fine. You can see what's happening. Debug, avoid it. But sometimes, you've just implemented a new feature. You want to know it's working. So you knock the logging level down to debug and you watch your stuff working. And then when you're confident or the error that you're looking for has been fixed, you then knock it back up to knock it back up to info. Production. I prefer to, as I was saying, I prefer to have everything at warn. One of my lead devs, Dom Davis, who some of you will know, he definitely thinks that you should have everything at info in production so you can see what's going on. But I don't think so. Debug briefly when you're debugging if you must in production. But the idea is to keep logs down, yeah, because they cost money. So let's think about structured logging. So some of you were sort of indicating this earlier. So sometimes you can add, in fact, in most logging applications, you can add context fields, so information relevant to the operation that's performed. I'll give an example in a minute. You should include information also in the log message. So it's important to make sure you have the relevant information in the log message and the relevant information in the logging context, because normally the log message is what's displayed in Datadog or whatever you've got, and you have to go looking for the context. And also, as David was suggesting at the back, include an identifier for the code location. So there's nothing worse than having an exception come up and you see it and you've got no idea where it is in the code. So as I'll give an example in a minute, it's important to include some sort of context information. You may also want to include the name of the service where the log came from, the IP of the service, because especially in things like Kubernetes, they're moving things around all the time and you may need to identify the pod that it comes from, all sorts of other things as well. When you've got a request, make sure you log the correlation ID. I'll speak about correlation IDs in a minute. You might want to also log the user ID, so you know which user was operating the software at the time that the error happened, all sorts of other things like that. So your context objects can look like this. So you've got your message at the top there, and then you've got the function bit of the context object, which says where the log message comes from, so you can find it easily. Then you've got other relevant information about the request that was made. You may store timings and those sorts of things. And then you've got the pod instance, you've got the IP address of the pod, you've got the timestamp. Forget who said that was Delph. Yeah, the timestamp is there, and then the service that was that did the log. And then an error one, you've got some other bits and pieces as well, including the exception. So you've got to the point where you want to log your exception, and you put that into the context as well, because just putting the error message from the exception into the log message isn't usually very useful. Correlation IDs. Do we all know about correlation IDs? Yeah, so you can follow your request all the way from your client all the way to your database and back. So you should make sure that every HTTP request has a correlation ID. If you have a client that won't give you a correlation ID, then create one at the first possible opportunity and pass it through the rest of the service and back. Stephen.
Why do you keep saying back?
Back?
Yeah.
How do you mean?
You say put the database and back.
Well, yes, because it's a complete request response, isn't it?
What?
So you've got your message passing through your through your service, okay, and then you call the database gives you data back, and then you do something with that data and pass it to the next layer, and then it gets to the boundary of the service, and the service passes it back to the client. See what I mean? Yeah. Cool. Log securely. Yeah. Don't log personal information, names, emails, addresses, phone numbers, those sorts of things. Don't log them because it becomes a data breach very quickly, and those get expensive. Don't log secrets, credentials, tokens, any sort of authentication type stuff. If you log them, someone can go into your database potentially and get them. If you absolutely, so log judiciously with good judgment. So log errors judiciously. If you log an exception, like I was suggesting earlier, okay, if you log an Axios exception, so the popular JavaScript library, it includes all of the headers. And the headers include the API keys and other bits and pieces. So think about what you're logging. Make sure, especially with exceptions, that you strip out anything that might be dangerous. Don't log anything unless you know you're going to need it. Yeah, don't log it unless there is a defined purpose for it. Equally, if you log loads of stuff and you end up with PII in there and you've got a problem, your blast radius is much bigger. You're going to have bigger problems. Don't bloat your logs. I'll talk about aggregators in a minute, but the more logs you send to your aggregator, generally speaking, the more cost there is. And if you must log PII, secrets, etc., mask them. Sometimes you're having something that's not authenticating properly and you want to check that you're actually sending the API key through. So log it, sensible thing to do, but just don't log all of it. Write a logging library. Yeah, so we were talking about cross-cutting concerns earlier, but often, especially when you're talking to aggregators like Datadog, they need to be configured in the same way. You need to make sure you're sending the same format, whether it's JSON or something else. So create yourself a logging library, okay, and then share it amongst your services so you're logging consistently. Logging aggregators, right? So think about where your logs are going. Okay, so strangely enough, most logging aggregators like Datadog will try and make as much money from you as they can. So they may well charge you for the egress, they may charge you for storage, they charge you for the amount you ingest, all those sorts of things. How many logs are too many? Think about the amount of logs that you are sending, okay, and what that's going to cost, and whether or not they're going to be persisted for as long as you need, which is what I've covered in the next one. So, for example, Datadog stores by default stores logs for 2 weeks, and then they get archived. You can hydrate them again, but it's difficult. And we use that much. So we have different archive strategies. So your archive is 30, 90, or 300 days. So you can go back and get what you need to get, and then think about what logs you need for alerting. Okay, so there may be some things you need to put into the log so that you can watch what's going on. That kind of contravenes the metric stuff because you should be doing that with your metrics, but sometimes it's easier to do it with logs. Good. Who's having a good time? Good. So who's disappointed that we're at the end? Yeah, thanks, Charlotte. I noticed you yawning most of the way through. Right, so we've looked at sharing data. We've looked at caching, testing, exception handling, and logging. Are there any questions? And did I mention I've written a book?